so page 400, here's some answers and here's some stuff. The most important thing you'd want to have is the description right, so let's make sure we just do those. So number one is just sort of weird, because what would you have for your description?
0, 0.
Nothing. There's nothing to describe. They didn't change the graph in any way. We would just make the graph that we have been making every day. Why don't you grab your book, see if you can tell me what's up with number 2 when we get there. Can you tell me what's up with number 3?
I don't know if I can.
Do you have anything written as a description or no go? Okay. Why don't you just listen to what other people say, because yours is similar to some of theirs. So see if you can find one that looks kind of like yours and see what that person says, and then we'll loop back to you.
2 times 12.
It is. Number 4 is 2 times as tall. So anybody that lands on a question that has a multiplying in front kind of number, that's a tallness issue. So number 4 is 2 times as tall. There's a bunch of these that have to do with tallness. What do you say for 5?
Right 3?
It is right 3. Anybody that has adding or subtracting in their parentheses, you're going to move right or left. And it's always the opposite of how it feels like it should. Like -3 feels like left 3, and it's not. That one's headed right 3. 6
Right 7.
is right 7. 7?
Left 4.
It is left 4,
down.
and it is also what?
Upside down.
Upside down. The
Out of
negative.
curiosity.
Anytime there's a negative in the front, we're going to go upside down. So 7 is upside down and left 4.
Out of curiosity,
Uh-huh.
what do I have to put to like label it? I just gotta put the vertex and just say if it's
We'll
up
get
or
to
down.
that in a second. Yeah, we'll need a vertex, a line, and symmetry, and a graph also, but I figure start with the descriptions.
Oh, I get you, Rosio.
All right. What do you got?
Is 2 just like sideways or something?
It isn't.
Sideways
Stay tuned, listen to a few more people, so then we'll see if you can build your guess. You ready to guess yours?
Yeah, is mine 4 times as tall,
It
and
is.
it flips as well.
Flips which way?
This.
Upside down, yeah. 3 is upside down, and it's 4 times as tall. That is true. So, I think we're to 8, right?
Yeah.
Okay.
Is it flipped upside down?
It is? It is. Flipped upside down and right 2. Number 9? Okay, let me come back to you for 9. 10 has 3 things.
Right 7, 4
It is.
times as tall,
Yeah.
and upside down.
It is. 11 has 3 things.
2 times as tall.
Yep.
Left 9.
Yep,
And flips.
it is. Upside down. 12?
2 times as tall is 7.
It is. 2 times as tall. Which way 7?
To the left.
It is left 7. I agree with that. 13?
It's 3 times as tall. Is it right 1?
It is 3 times as tall. It is right 1. Somebody volunteer for 14. Yes, sir.
So it's flipped
It is.
sideways and upside down.
No, just upside down.
Okay. Oh wait, yeah, and then it's 4 times as tall.
It is.
And, right 2.
It is right 2. That's all true. 15, what's up?
It'd be 3 times as tall.
It is 3 times as tall.
And then go right half.
It is right, half a square, so that's going to be a weird-ish graph because everybody's going to be in the middle of a square, never at a corner of a square,
So circumference.
and it's upside down.
So would 2 just be like it just puts upside down?
2 is just upside down, yep. 16 up for grabs. 2 times as tall.
Left half.
Left half a square,
Upside down.
upside down. 17, somebody?
Half as tall.
Half as tall.
Left 1.
Left 1, all true. 18?
3/4 is tall, right 2.
It's right 2, I don't know where you pulled a 3/4 from.
1/3.
1/3 is tall. 1/3 is tall, and right 2.
I'm really not good at numbers.
Yeah, I didn't know if you were hallucinating or something for a second or whatever.
That one just a little bad.
Okay.
Just a little.
Yeah, it could be both.
I think the most important thing to be able to do is understand how to come up with those descriptions. If you understand that, you understand a little bit of 9.3 and a little bit of 9.2 as well. Other days, we also did some wideness graphs, and that didn't come up here. We also did some moving up and down graphs, and that didn't come up here, but that kind of covered about half of what we did in this chapter. The tallness, The upside downness and the right leftness all got covered there. Question about stuff on the description?
So, I get the, like, for 17, the 1/2, but for 18, how do you do the 1/3?
You have to just kind of guess it.
Okay.
It's
Like a third of a square, you'd kind of go up, not
third.
quite a
Yeah,
half.
I get that one, but like a third of 4.
Okay, so 4/3 is like 1 1/3.
Okay.
So go a square
And
and like a little bit more.
How
You
would you
kind
do
of
like a
guess it, you
sideways?
know what I mean? That's what I
How would
do.
you do it?
Which roads are those on?
On these, since they're used, they didn't make them go sideways because it's the same thing. So they had done that another day. What makes it go sideways if the negative is multiplying in the parentheses. So if I have some like an x that's getting squared and I do the negative there, it would try to flip it sideways, but it's hopeless. If I do the negative there, then it's
Oh,
upside
so I would move it left or right? Not up or down.
Similarly to, all of these
Oh, no,
were
left or right or up or down?
the right lefts,
I think it
like
is.
that was left 3. If I want to go up 3, I've got to move that out. The question is about in or out. Anything in goes in the x direction. Anything out goes in the y direction. Anybody else 400 as we do the descriptions? Question about how to do descriptions. Did anybody get mad at the graph on any of them? Anybody have angry graphing experiences? Let me just pick a random one and do it. Let me do like, I don't know, 14 is kind of big. So for 14, what did we decide was happening for 14 in terms of our description of the game here? It was flipped,
4 times taller.
4 times taller, and right 2. So what we're trying to do is come up with a vertex, come up with a line of symmetry, and make ourselves a graph.
2, 0.
The vertex is 2, 0. We could either find that first or make the graph first. Where would we start our graph? By going right 2. So being right 2 means that's where the graph starts, and that means that the point that's called the vertex is located at 2, 0. Anybody have a question about how the right leftness is deciding a thing called the vertex? Okay, then let's make the U, then let me decide on the line of symmetry. If I'm upside down and I'm 4 times as tall, where should I move from home base? Right 1, down 4. Because usually we're over 1, up 1. So we're over 1 still, but going down, because it's flipped, and go times 4. 1 times 4 is 4. So I'm going to go those. And then over 2's, down, I heard an 8, I heard a 16. 16. Because usually for the squares, over 2 goes up 4. But times 4 is 16, but not up anymore, but down, because we're flipped. So 1, 2, 3, 4 more is 8, 9, 10, 11, 12, 13, 14, 15, 16-ish. This is why graph paper always beats boards. But over 2, down 16, over 2, down 16. Make ourselves a U shape. And then there's a thing called the line of symmetry. You don't have to draw this in your graph. I'm just drawing it to show what it's about. The line of symmetry just does what? Makes the 2 sides match. Or in other words, it takes the shape and cuts it exactly in 2 perfect halves. Vertical lines, what's always the equation for all vertical lines in the algebra world?
X equals 0?
X equals somebody. It's x equals 0 if we want to land on the,
Over to.
what's this called? On the y-axis. X equals 0 would be landing on the y-axis. But we got nudged over a little bit to a spot where x equals 2. The line of symmetry is always going to have the same number as the vertex. It's always going to be an x equals line. So as you go through the rest of this homework, Every vertex is going to be an ordered pair, somebody, comma, 0. Could it be 0, comma, 0?
Yeah.
Yeah. The first couple are. The first couple answers, the vertex is 0, 0. And eventually, what makes it be somewhere else 0?
If the number's in the parentheses.
Which part of this description made that change off the origin?
Right.
The right to. Anything that had a right left, you're going to get number, comma, 0. Anything that didn't have a right left, your vertex is just at 0, 0. So maybe 30% of those answers, I think, were at 0, 0. And then 70% of them probably you moved around right, left. But vertex is somebody 0. Line of symmetry is x equals that same number. Might be 0, might be the number that you moved right or left, but x equals whomever is always the equation for the line of symmetry. And there's a bunch of U-shapes. I don't plan to graph 18 graphs. I don't plan to read you 18 of those other answers, but that's what's up with those. So what you should have on each problem is a description that kind of runs the problem, a vertex that is somebody 0, a line of symmetry that's x equals somebody, and these numbers should always match, and then the graphs are all just a little bit different than each other. Looking at your paper, which graph does 14 look the most like?
Number 5, I guess.
I wouldn't say 5, no. 14's the same basic shape as 2 other ones.
Oh, number 8.
Nope.
I think I'm looking at it.
I got 10.
14 and 10 are they're twins. They're just located in a little different positions. And there's one more that makes them triplets. No, 16 is, there's a lot that are shaped like 16. Anybody have a thought? Other than 14 and 10, who else is shaped exactly the same? No, 9's a little skinnier. 3. Yeah, 3, 10, 14 should all be twins, triplets, because they're all like a 4 times as tall upside down is in there. Where they're located is like a little different from each other, but yeah, 3, 10, 14 should all basically look like this, just be in a little different spots. Anybody with a 2 in the front, they should all be the same size and shape. So like 4, 9, 11, 12, 16, those should all be the same shape. Some of them are right side up, some of them are upside down, but those should all be the same shape as each other, just kind of moved around a little bit. The ones without numbers, 1, 2, 5, 6, 7, 8, those should all be a family of exactly same sized graphs. Some are right side up, some are upside down, some are moved, some are not, but those should all be basically the same shape as each other on those. 15's 15, 13 are 2 of a kind. One's right side up, one's upside down, but they're the same as each other. 17, 18 were each one of a kind. Nothing was shaped like that. But I'll graph more, I'll do more if that's going to help people for me to do more.
What was the description?
1, I would just say no description. Just make the basic graph. It would be just origin, x equals 0, and make that graph that we've sort of memorized it hopefully over time.
Why do you have 2 lines for the practice quiz?
Because there's symmetry to the line and there's symmetry to the point. So you're going to say like no, no, or yes, yes, or no, yes, or yes, no.
I didn't think I would have caught that.
That's okay. Anybody else question about 400? Anything more you want me to do about 400? Anybody want me to try to revisit other pages that you're struggling with from 396, 391, 386, all alive, 4 sections alive before we feed into the review sheet tomorrow? Anything on those pages to do? Yes, sir.
So on 386.
386.
I
Okay.
have no idea what I'm supposed to do for 1 through 6.
Okay, so for number 1, symmetry to the line is where you see if something mirrored itself across that line. So if I draw you a line like this, and over here I've got this, this, and that, if I'm gonna create symmetry to that line, the rest of my drawing's gonna create a happy face. Because it's gonna make that mirror match. If both sides mirror match that symmetry to the line. You okay with that?
Yeah.
Symmetry to the point is, if I drew you a circle, I could show you symmetry to a point if I put the point there. Because this is a match for this. Because they're the same distance away and they all line up. This has a partner there, this has a partner there. Any point I pick has a partner where they're the same distance and they stay in a line. That would be symmetry to a point.
Class.
But if I did this picture and put the point there, that's a big no. Because even though this, I guess, has a partner there, like those are the same distance and they're in a line, this, if we go same distance and try to come out the other side, this has no partner over there, that's just empty space. You're just lost in space on that one. So symmetry to a point is every point on the drawing has a partner point that they can stay in a line and be a mirror match of same distance.
Alright.
Is that okay?
Yeah.
We have to change the signs to figure out for like the x and y axis for the origin. What does it mean to get the equation the same again? Because my brain simply won't make it work.
Okay, so this, if I tried to change the sign on the x, the square would erase my attempt, and I'd end up in the same place. So that would be symmetry to the x, or symmetry to the y, because it's always the opposite variable. If I try to switch the sign here with the y, there's nothing to prevent me from doing that. I would have changed the equation, so that is no on symmetry to x.
So like, say it was still squared, but there was a number in front of the x squared.
The square still would erase my attempt, it would still be symmetry to the y, like if I put a 4 there.
Yeah, but if it was like a -4, would that?
If there were a -4, no, because I still wouldn't have changed the sign, it would have been stuck negative. This is stuck positive, that's stuck negative, because this is permanently unchangeable. If I go to do symmetry to the origin, they need to either all change or no change. So the way this sits now, this would be stuck as positive. This would be changed by me, mismatches, no. But if I do that, now I try to switch this one and it can't. I try to switch this one and even powers say no. This didn't even have a letter, so nobody would get the change. I'd say yes, symmetry to origin.
Okay.
If I went like this, that one's changing, and that one's changing, but that one's still not. I still say no. Now I say yes, because now they'd all change.
Okay. All change or no change for origin. Okay.
Now I say yes, because I got no change. But if I mix and match, then you say no. Anybody else? Anything from any page that we've done, any lesson of anything? I can tell some people are already peeking at the review sheet and asking me themes off of that, and that's fine. That's what we do tomorrow. 387, 28. So the rule for testing for symmetry to the origin is you try to switch the sign on the x, and you try to switch the sign on the y's. And if when you do that, nothing actually happens, you say yes. If you try to do that and everybody switches their signs, you still say yes. You say no if like some stuff would change and some stuff would not. So if you go to attack 28, if you try to switch the sign of the x to be like a negative x, the squared erases your attempt and that did nothing. If you try to do the same on the y, the even power erases that attempt too, and you did nothing. And the 4 didn't even have a letter, so you did nothing there either. So since you accomplished nothing, you say yes. But if I changed one of those even powers to an odd power, now you'd say no, because you would have had some change and some not change.
What makes the like squiggly ones like flip this way?
If I put, okay, so a sideways flip is if I go negative right there. So if I go a negative in the parentheses, that's where the rights become lefts and the lefts become rights.
Okay.
So if you're looking at 396,
Doesn't look like there is.
they're, number 27 and 26 are gonna go sideways.
Oh, okay, yeah. What did this go up to?
27.
27.
Yes.
The,
Even and odd. So even, there's a shortcut that works most of the time. And then there's a longer way that works all of the time. So if I say something like this, since those are all even powers, it's even. If I throw in something like this, there's an invisible 1 there. Now that's nothing. If I happen to throw in a number like 5, that has an x to a 0. This piece is even, that piece is odd, this is even, this is even. If I did all 4 of those pieces, that's nothing. But if I went like this, now I'm back to even because they're all even powers. That'll get you through most of them. Okay, the rules to get through the rest of them, if I decide to start to do like fractions or other crazy things, even means the same thing as symmetry to the y-axis. The rule for symmetry to the y-axis is find all the x's, try to change their signs. If nothing's changeable, then you're okay. That's a more confusing way to explain that, but you don't usually need that explanation. And then odd is the same as symmetry to the origin, which means you try to switch the signs of the x's and the y's both. And if nobody changes, you're good. If everybody changes, you're good. And if you get a mishmash, then you're bad. But you don't usually need that test. But it exists. So like, are you looking 387? Or are you looking at a sheet? Okay, did the sheet have any that aren't just stuff like x squared plus x cubed plus 7? Do they all look like that? Or are there any like really weird looking ones?
They're not 3 pieces.
There's no freaky ones?
There's no 3 pieces.
Okay, but they're like, but they're all just stuff adding stuff. So you don't need the hard definition for the sheet. Yeah, the easy system is enough to get the sheet done. Just the only thing you need on the sheet to know is when you just see an x and you don't see a power, there's a 1. And if you just see a number and you don't see the x even, there is still a 0 there. So any number is going to turn up as even because every number has an x that has a 0, and 0 is considered an even function. This has nothing to do with even and odd numbers. Even and odd functions is based on the powers, not on like the coefficients. So like when you're in 5th grade and they say, what's 7? It's an odd number. That's not what we're talking about. I'm talking about that has an x to the 0, which is an even function, which is a whole other like category of life. Okay, does that make sense?
So if it's just to a number, it's even.
Every number is even. And there's one very special number that's both.
This is 0.
Is 0.
Can you read these and tell me if I'm going in the right direction?
I can, in just a second, let me make sure nobody else has anything that's like recordable before I just disappear off camera. Break my audience's heart because I'm gone. Anybody else have anything from a page while I'm in view site here? Any kind of questions from any pages before I start making individual visits to my in-studio live audience? All right, that's a wrap.